speciaal voor deze meetup mijn haar laten groeien. Zodat ik geloofwaardig overkom.
Je gebruikt al PowerPoint.
That's by PowerPoint. Of dit allemaal werkt. Ja. We doen het in het Engels, heb ik begrepen?
That's the request. Yeah.
Okay, no. I can try. Okay. So thanks all for being here and the time to listen to VMware and what the heck is VMware doing in OpenStack and containers. Anyone who's aware of what VMware is doing in OpenStack and containers? Yeah, I know you. So you can go out of the room. I think you know most of this. For the rest of it is probably new. Because no one bothers to look at VMware when they talk about these new open source technologies. Which, no, it's kidding. It's kidding. Let's have a look where we are. Put it on. If you stop the sticker erin. There it is. All right. So what's happening? This is all the. Everybody talks about this Uber and Airbnb and those companies, so that's why I have some different names on here. Reason, because it's all about user expectations, customer experience. That's what's happening in the marketplace at the moment. And especially when you look at, for example, John Deere, I think that's a very nice example. John Deere is becoming a software company as well. So what's happening? They used to build tractors. But now the instrumentation on those tractors becomes more and more relevant, because those tractors, they go over the land and they take samples from the soil and they send data from where it's wet and where it's dry and all this stuff. So they create the data for the farmer to improve his business process. So it's just a matter of time for a Chinese company to come around with a just good enough tractor with awesome instrumentation to take John Deere out of business. So they saw this and they now got a John Deere API. So you can develop with John Deere. You got an API, so you can instrument the tractors and everything. And so even a company where you never thought of that would be going into this new modern stuff, they are. Or Sonos. Kit Colbert, he will be presenting at our VMUG in March, so shameless plug there. He's a San Francisco guy and he needs to have a new system in his house for audio. And a lot of technology guys like here I know, when they look for audio, they look for big amplifiers, thick cables, expensive stuff. But nowadays, these new guys, they're looking for, okay, what's the user experience? Where can I stream it to? What's the expectation? What app comes with it? And then, and as an afterthought, oh, does it sound any good? Well, that would be nice. So it's really changing. So what's happening? 4 forces that are shaping the industry. We see DevOps, which is the cultural side of the house. We see Agile as development methods. We see containers, and we see microservices as an application pattern. Those 4 things coming together, they are changing what's happening now on the technology front for the industry. So then we come into whatever it's doing, continuous delivery. And this is what everybody's trying to achieve and how they achieve it. They want to do frequent releases with small sets of changes, but even if we have a very good CI automation, CD is still a different thing. And continuous delivery, then you still get a lot of manual steps, typically, that people want to do, and they create their own integration, their orchestration, and try to put it all together to do that. Because what do developers want? They want to push into production as fast as they can. And what does operations want? They want stability, change is evil. So there's a DevOps crisis, of course. So this is the application change from monolithic to microservices. Microservices, so every part of the application can scale autonomously, independent of the other ones. That's I think the easiest way to grasp what microservices can really deliver for applications. So how does that look like? What are we doing? Linux containers, applications in there. This is the way people typically deploy these this new stuff. So why do they do this? Because of isolation. We've used virtual machines a long time for isolation, but now with containers we've got more granular ways of isolating in smaller chunks, so we can do that. And people did that already for years with software zones and everything. So that's nothing new in here. So that's also why we are very interested in this. Well, this is Docker. This is the plug for Docker. Well, they were just on stage, so I don't need to repeat why people are so cool about Docker, and developers love it, because they finally have the freedom to do what they want to do without interfering with all the infrastructure guys. So they can do DevOps on their own without infrastructure. So why did Docker become so successful? Because of the portability, the compatibility, and the way they don't need to talk to operations to get something done. Because that's the main reason. So it's the fault, if you want to say it's a fault, because I think it's a good movement. But it's actually the fault of IT operations that this became successful so fast, because they've been holding the infrastructure to themselves already for all those years. How many have this API, have an OpenStack API running? Okay, here's the API, here's your quota, go ahead, figure it out, have fun. There's very few companies that were able to do that, or were doing this. So that's why people are looking for ways to get around that, and Docker is a very good answer to do that. So it's a natural fit for modern applications, third platform, 12-factor applications, microservices stuff. It's not the best way to run SAP HANA, for example, a container. I don't know, what's the biggest Docker container you guys have seen around? Anyone? What's the most exotic big thing you've seen anyone deploy in a container because he can? Hmm?
OpenStack?
OpenStack inside a container.
Yeah. Cola?
Cool. Oh, that's a pretty neat use. So what are we doing with cloud native apps? Because that's where it's all heading. That's why we are doing all this stuff, OpenStack, containers, DevOps. Because of the cloud native apps, because of why John Deere is getting into a software business as well. That's what it's. So our mission is simple. Make the developer a first-class user of the data center. So open up the data center, give him an API to do what he wants to do, to get frictionless infrastructure and get it working. That's what we do. So shift gears a bit into OpenStack. So to do that. So, and we want to do that with open systems and open standards, and OpenStack is one of them. So let's go into OpenStack. How many of you knew that VMware actually has an OpenStack distribution? Show of hands. Yeah. 40%. So 60% of people are unaware that we have an OpenStack distribution. We do, and it's not a bad one either. And the best thing, it's free. Yeah, free. Free as in free copy. No, it's free, but customers are already paying for vSphere. Chris already said it, VMware is an issue, they're too expensive with the hypervisor. We can have discussions on that, but it's not the purpose of this presentation. We'll do that over beer, that's what meetups are for. But I still see a bright future in what we're doing. If you look at the bottom, you see vSphere, NSX, vSAN, all that nifty VMware stuff that we're doing that we call a software-defined data center. That's what most of our enterprise customers are deploying nowadays. But they also want to open up this new modern infrastructure, open API, to consume it in an automated way. And on the side here, you see even the management tooling. If you realize operations, log inside, business, financial management, everything. Because that's not what OpenStack delivers you. OpenStack doesn't come with any monitoring tool. OpenStack doesn't come with log management stuff, doesn't come with chargeback facilities for who's using what. So you still need to do a lot of that. And even what we see, and I think that's where a lot of people go wrong, because looking at the price of the hypervisor is one aspect. OpenStack doesn't come with infrastructure. You need infrastructure, and if you got an infrastructure, you can put OpenStack on top of it to open it up. So you still need to build a good infrastructure. And it happens to be that a lot of our customers are doing that with our stuff. And they don't want to set a new silo next to it. Because that's what I see a lot of times happening or being proposed to open up a new silo for cloud-native applications. But in that new silo, you need experience, you need knowledge of the hypervisor, all the tooling and everything in there. So a lot of enterprise customers that are not running one application like Uber, they can create this snowflake of this unique infrastructure for themselves, but they got hundreds of applications, and now they want to do something in a new way as well. They don't want to have the headache of creating a new silo next to it. They just want to use the infrastructure they already have in a new way with an API. So that's why OpenStack or VMware comes in, and that's what you can use. So here are all the components that are pretty familiar, I hope, from what OpenStack delivers. The gray ones are just the generic ones, and the blue ones are the specific VMware integrated technologies we did. So we integrated, of course, with vCenter, with vSphere. We integrated NSX, the network virtualization platform, which makes Neutron really rock. We did the vSAN or the other storage integrations, everything in there. And all the work we did is upstream, so it's nothing proprietary. It's everything we do, we deliver, we commit to it, and it gets upstream. So nothing specific there. So it's all in there. So our purpose is make OpenStack easy, and that's what everybody says and everybody does. But we actually have seen it. I've seen customers upgrading their infrastructure from Icehouse to Kilo with one command line, and it worked. And they had it running, and it just went from the next the Icehouse to the Kilo release. And that shows that we put really a lot of effort in there. So how did that come to bear? How did we become so good at OpenStack so quick? Because you were wondering, you are this dinosaur guy doing this hypervisor, and now you're saying you're a really cool OpenStack distortion. How do you do that? Well, the answer, the smart sauce, is Nicira or NSX. We bought Nicira, the guys that essentially wrote most of the Neutron API, and they came with a very huge KVM environment with multiples, with a very big OpenStack environment where they built and produced the software. So we got this knowledge in-house. So all the work they did, we shamelessly stole and packaged it up as a product and used that. So we use Ansible for creating this. The deployment of VMware OpenStack is really easy. Even I can do it. And that says a lot. It's really easy. You can just download an appliance on your vCenter, you register it, and then you start the configuration wizard, you walk through it, and 15 minutes later, you got a working OpenStack environment with all the instances, with all the components in there. It spins up somewhere between 15 and 20, depending on your configuration, virtual machines to run all the components in there. And it's running, it's done, it's ready. Anyone who has seen, tested, or played with VMware OpenStack here? One? Anything you can and want to share with the rest of the people here?
No, I use it as a. I'm not using it kind of like deploy it or as a proof concept. I'm looking for for the tenants for our customers, so it's okay.
So you deployed it as a POC,
Yes.
and the experience was okay?
Yeah, the first time, yes.
It just works.
If that's the answer you want to hear, yes.
Well, it's that's what I typically hear from people. Well, they are surprised that it just works, because a lot of people that are doing OpenStack for a while have different experience, and it's not that trivial to set up an OpenStack environment, and it's not always just works. So that's why. All right, moving on. So it empowers you to deploy it really in production. It's a production-ready system. No OpenStack PhD. Let's get it on. So here are some examples of customers we have. If you look at the top, you see some names of people that are using our stuff as well. So Yahoo, Amadeus, Nike, Adobe, Wells Fargo. You can find them all because they've all had pitches on the OpenStack summits. So they're all on YouTube if you want to review what they presented about it. Well, that is what it is. So, the VMware Cloud Native stack. All the blue boxes our stuff in the cloud native application space that we do something. So on the left you got the developer. We deliver App Catalyst there, so it runs Vagrant and Animax. We got in the development lifecycle, we got a product we call vRealize CodeStream, which is an addition to vRealize automation to integrate with all the stuff you see below and 100 things more, to do pipeline release management. And on the production stack, because that's where we really shine, when people really take the leap and go forward and go into production, we have all the stuff you know there, but also some new stuff. So first into the developer, we have something we call App Catalyst. And App Catalyst is just a hypervisor that runs on your laptop. And that's fully CLI based for automating development work. So you can run virtual machines on your laptop. It's free to use. It's integrated with Vagrant. It shipped with Photon OS, a very lightweight Linux optimized for running in virtual machines. And it's just there. You get it from Get App Catalyst or get it from GitHub or whatever you want to take it from. So this is what it looks like. You run it on your desktop, then you have your networks and storage abstractions. That's what we're working on now to get the same experience exactly in the data center of that. So if you're, and then you can run containers on top of that. So it can be any container, it can be Docker, it can be any other container as well to integrate. So the Docker machine API can talk into here, and you can just use that. Then we have on the development lifecycle, we realize CodeStream, which is essentially a pipeline release management tool. So here you can do the full delivery into continuous delivery for test, UAT, production, everything. And that of course integrates with all the stuff that people typically use. It comes with an artifact management tool integrated with JFrog. That comes with the tool, and it integrates, of course, with all the typical stuff that people use to do CI/CD. The power of this is that you get a consistent view of what you're actually doing. So if you run multiple pipelines next to each other with different software versions, you can see where it is and what the correlation is. So if you do an end-to-end business process across multiple releases or multiple pipelines, you can have the overview of what's happening and where it's going. That's a really powerful tool. We brought this to market because we developed this for our in-house use. We happen to have a couple of developers ourselves in VMware that produce a lot of software, so we felt that need, so we developed this, and we productized it to have other people benefit from that as well. Then go into the cloud native application stack. So then over to the right when you go into production. So what's happening here? We go into PaaS, Platform as a Service. And this is really a topic true next to what I'm experiencing recently, because I see more and more interest in Platform as a Services. And that's a bit contradictory with what I see what people are building with things like Docker or Kubernetes or Mesos and that kind of stuff. So we're not opinionated. We want to deliver every possibility. So we are supporting and developing things to optimize things like Mesos, Kubernetes, Docker, whatever. But we're also looking at PaaS in a different way. And the reason for that is there's two ways of doing a PaaS. And here it says you got unstructured and you got structured. So unstructured PaaS is what a lot of people are doing. They create snowflakes for specific applications that are very unique infrastructures to run a very highly optimized environment for a certain specific application. And like I said, it's very good if you are Netflix, Facebook, Uber, or whatever. If you have one application and you run that at a massive scale and make all the efficiency you can get, and you can put all your R&D into that platform. And it's a very good way to do an unstructured PaaS and mix and match the tools that are available in the market to build that. But if you are an enterprise and you want to also run agile DevOps and stuff, but you don't have one or two applications, but you got hundreds of applications, you don't want to create 100 unstructured passes. You don't want to mix and match all these components for 100 different applications and do things in a different way, because every application needs a different optimization. And that's where structured pass comes in. So then you look at things like OpenShift or Cloud Foundry to do that. That is a structured pass, which we also call an opinionated pass, which means it has an opinion about it. So there are some guidelines that you have to adhere to use that platform. But if you do so, you get all the goodness from the platform by default. You don't have to engineer it. In an unstructured pass, you engineer everything yourself. In a structured pass, it's already there. So if you put an application on this pass, it's already high available, it's already auto-scalable, it already has all the features that the platform delivers you. And that is, I think, if you look at where people are looking at containers, because the platform runs containers. There run containers inside Cloud Foundry. And you can run Docker files in there as well. But if you put a Docker file on top of Cloud Foundry, you start to think, what am I trying to achieve here? Because I'm doing a wrapper on top of a platform that already has all the features that I had the wrapper for in the first place. So why don't I just push the code? Why don't I just push my application code into the platform and let the platform take care of the rest? Because if I put a Docker container in there, I still have to think about how to scale it. You have to have multiple and have to talk to each other. And if I put my application code into that platform, it takes the application code, it recognizes it. Is it Java? Is it .NET? Is it whatever it is? And then it takes the components, it binds it to the right components, and it scales it, and it runs it. That's a big difference in platform as a service. So what I see a lot, and I recently had the joy of a customer deploying this, and he called me yesterday and said, this is brilliant. I just got an email from the system that it says that it scaled my application because they're running indexes on the application. I didn't care about it. We just pushed it in. It runs there and it scales and it does it. So everything is there. The scaling is done, and the fun about the Cloud Foundry is that it's not even a complete list. It can run on vSphere, you can run on vCloud Air, on integrated OpenStack, but you can also run it on any other OpenStack distribution, and you can run it on AWS, and you can run it on Azure. So this way you got now a platform that's infrastructure agnostic. So you don't care what infrastructure it is. So if there's a way you want to get rid of VMware, and you want to do it in the best way possible, go to such a platform. That's really the fastest way to get rid of VMware. Because if you create this platform, then this is your interface. And then you can just change, replace, you make availability zones, just like with EC2 underneath this, and you can go whatever you want. So essentially you can create a RAID array of platform services. So you can have multiple, you can have 5 different providers here. You can run the platform on top of that, and it scales, and when one of the providers drops out, if your application is written correctly to 12-factor microservices and everything, so if the state is preserved, then it just continues to run. And that is, I think, the essence of what we're trying to achieve. Not if we want to put it in what kind of container or what kind of a wrapper or something like that. Because that's actually looking at what are we trying to achieve, hence the title of this presentation. Some stuff that runs in there. So what you can do, the experience is push. You can say push and it works. So you said push var, push.net, push Dockerfile, and it just spins it up and it runs there. So that's the easy thing. So it's got all the high availability, everything in there, and it integrates with well, everything you can see here. This is, I think, a real bright future, because infrastructure as a service only brings you so far. If you want to run applications, you still need stuff on top of that, and that's, I think, a good way. Moving on to, if you do want to build your container platform, because you have a good reason to do so. So you figured out, okay, PaaS is not for me because I'm doing something that doesn't fit in there. I want to build my Snowflake purpose PaaS for this application. Then you want to have containers running, and you want to be able to do that. You can do that in 2 ways, according to VMware, which is the integrated containers way or the Photon platform. And I will explain to you the differences on what they are. So integrated containers is an extension to our vSphere platform. It's showcased already. It's It's in beta at the moment, and it delivers you the ability to run containers as first-class citizens on top of the hypervisor. So kind of like a unikernel, if you will, for containers. So what happens before and after? So we have, oh, it's an animation I didn't practice, sorry about it. Docker. So we give the command to vCenter, it's a Docker machine. The VM gets created with the Docker engine, so that exposes the Docker API. So when that Docker API is exposed, we hit the Docker run command. The Docker containers are created inside the virtual machine. So that's what typically everybody does nowadays. Even people that don't know that people are using Docker in their environment, I just ask them, okay, have you recently had some requests for new virtual machines that are pretty big on Linux? Yes, we have. So, well, good chances they're running Docker in that, because that's what people do a lot. But it's a suboptimal way, because you have a lot of bloat, you got a lot of overhead, you got all this stuff, all this virtual machine, the start time of the virtual machine. So we want to do it differently. So with virtual VMware vSphere integrated containers, there we go, we create a virtual container host, and the virtual container host exposes the Docker API, and the Docker micro VM is created. So then we have the interface, we get the Docker run, Docker start, and that talks to vCenter and then starts your virtual machines. It creates them, it starts them, stops them, and deletes them. But what we are doing, we're not just cloning a regular virtual machine. We are instant cloning virtual machine. So we got a concept, we call it just enough VM, which is a micro VM, and it's actually a fork. So we are having a virtual machine as a parent, that's our stem cell, and then we do a fork in memory of that virtual machine. So there's no footprint at that, unless something runs there. So as soon as it starts running, all the things that are running inside this forked VM, they are starting to consume footprint of infrastructure. And that way we can deploy VMs like this. So you can just have a container run on top of such a VM in a one-on-one relationship, because we can do that easily. So now we can scale in the way you want to do with Docker, with the speed that you are used to and running this natively. But you now have it running in VMs without the overhead. But you got the operational advantages of network isolation, you got the management tooling around that, you got the monitoring around that, you got the objects that that your operation still understands, because they now know that the Docker name that it creates is directly visible in vCenter. So the vCenter name of that virtual machine object is identical to the Docker unique ID. That's a one-on-one relationship you can see. So it becomes very transparent in your total stack to do this. But still, vCenter can only take so much. So if you say, I want to run 1,000 VMs in 1 minute, then vCenter says, got it. I don't get it, because it doesn't scale. It's a choke point. vCenter is your bottleneck there if you want to run 1,000 VMs in a minute. So therefore we came up with a different platform, and that's the Photon platform. So if you're running containers at such a massive, crazy scale that you can't cope with vCenter anymore, then we can help you with the Photon platform. And the Photon platform has a focused feature set, which means it's built for cloud-native applications. So the Photon platform is the AE6 hypervisor, but it doesn't have HA, it doesn't have DRS, it doesn't have emotion, it doesn't have all the stuff that you don't need. Because if you run a third generation platform with real cloud native applications, and you want to do it as optimal as you can get rid of all of that. But you still have that talking to the same management tools, the same stuff that you're used to in your environment. And this is also not a license model, so luckily for you, Chris, if you want to go crazy, this is just a subscription model. You only pay for what you use, like we are used to with most open source distributions that people are using in enterprises. And it's got a scale out control point, like I said. So if you now are starting thousands of VMs simultaneously, it just gets distributed across the platform and it does it for you. It's a distributed system. This is really a crazy new way of VMware moving away from their traditional hypervisor. Everything runs as we used to, because this is a totally new platform. It uses, of course, the goodness that we've learned, but it's purpose-built for what it does. It consists of a couple of stuff, photon machine, which is the hypervisor thing, and photon controller. And a photon controller is already out on GitHub. It's an open source project. You're very welcome to participate, fork it, or whatever you want to do. It currently supports a couple of cluster systems. It supports Cloud Foundry. We're also going to ship a bundle with Cloud Foundry together with Photon, because it's a good match. It supports Kubernetes, supports Docker, supports Mesos, but in a different way. And I'll show you how. So what's in it? It's the host controller and scheduler, the distributed control plane, and the Photon machine, the underlying, the microvisor. That's marketing got really hot on this. They don't have a hypervisor anymore. We now call it a microvisor. So you can only almost see it as a unikernel now. There you go. So what's the architecture and what's happening here? So we got the Photon controller, and it's multi-tenant, so it can, or it's distributed, so you at least have 3 of them to have it scalable. And the Photon API. And the Photon API is not very interesting. We're not going to expect that the whole world is going to go hung up on the Photon API, because that's never happened with any VMware API, so we're not betting on that. Why is the Photon API there? You just give the command what you want to have. And the command could be, create me a Cloud Foundry cluster, or create me a Kubernetes cluster, or create me a Docker Swarm cluster, or create me a Mesos cluster. That's the command you give to the Photon API to deliver a new infrastructure for a new system. And when that's instantiated, then you got this created automatically, everything's done. By magic, you got a Kubernetes cluster with the Kubernetes API. So you can now start using that Kubernetes API to do your application stuff. So this is multi-tenant. So you can have Cloud Foundry next to Kubernetes, next to Mesos, next to Docker, next to whatever on one platform, and create your Snowflake passes, as many as you want, as fast as you want. That's what Photon platform is for. So that's really, and people like Uber, they are talking to us, they are interested in this and trying and testing this out at the moment to see what it's like and if this fits their bill. Because those are the companies that are the first suited, of course, for this kind of infrastructure. So essentially, 2 flavors. vSphere integrated containers. That's what everybody can turn on their existing infrastructure. Just say yes to the developer, I want a container, I want to do Docker, instead of saying no and give them just a big Linux VM. So to do that, to does not have those resources spilled out. And we got the Photon platform for large-scale API, purpose-built. Like I said, there's a bundle announcement already for Pivotal Cloud Foundry, which I think it's got far more interest for people that want to deliver scalable applications, because you don't have the fuss and all the work of creating and building all this custom-built PaaS infrastructures yourself, because it's hard work. People like Netflix, they do a lot of engineering to do that. And the fun thing is that the entire Netflix OSS stuff, so the circuit breaker technology and everything in there, that's built in to the Pivotal Cloud Foundry platform already. So if you want to use Netflix circuit breaker OSS stuff, it's in there, it's in the platform, it's just a function you can call. You build an app, you say, okay, call circuit breaker, it's there. You don't have to build it, you don't have to fiddle around. That's the way I think that application development can do a big time. Because everybody wants to do this cloud native stuff and this modern stuff, but in an enterprise it's hard to do it at scale and do it in a good way. So that's why they say this is the way you want to innovate like a startup, you want to work like a Netflix and Airbnb and Uber, but you want to run it like an enterprise, because you don't have one application, you got hundreds of applications. And they now can share the same platform from an infrastructure layer and from a platform layer. That's essentially what VMware does in this space for presentation-wise, and I'm very open to all your questions.
Anybody?
Hey, so you mentioned very easy OpenStack upgrades. So how do you approach upgrading OpenStack?
Well, the easiest way now is just to run the YouTube video because it shows the demonstration of what it does. It creates a new one, then it moves the IP address to the new environment, and it removes the old one. That's the essential, simplest way it does it. But it's all worked out already, so it doesn't interfere a lot of manual work or a lot of knowledge.
Okay, so in other words, you're spinning up a secondary OpenStack cloud and moving your resources to the other one. And at some point in time, both clouds are somewhat operating at the same time, or does it happen at a single point in time that you switch over to the other cloud, to the upgraded cloud?
You can choose yourself. You can either have them running in parallel because you want to have workloads to give the opportunity to do so, but there is one point in time where you move the IP address of the API to a new port.
Okay, thanks.
Any more questions?
Microphone doesn't bite.
There we go.
Containers, they expand, have dynamic memory, like any application running in application space. Typically, VMs don't. That's one of the major differences between VMs and containers. Do these Photon containers have dynamic memory which expands like in milliseconds or microseconds? Or does it take like the old technology used in VMs? What's it called? I forgot the name, but
Yeah, hot add.
well, hot add and then the bubble, what they call it? Ballooning. Thank you very much. Yeah.
No, we don't assume there's a complete VMware tools running inside of there that to handle all those ballooning stuff. So it depends on your stem cell. So typically Photon platform is built for cloud native apps, which are used to scale. So you set a stem cell blueprint that matches the stuff you put in there. And typically when you write your application, when you want to scale, you don't scale up your content, you don't scale up, but you scale out. That's how you typically write those applications, because that's the cloud native pattern. So there's no need to do that. You can either scale out or it depends on your cluster controller, of course, because Kubernetes has a different way of doing that, as Mesos, as Swarm. But you typically leave that up to the container orchestrator to handle that for you. And that just takes the infrastructure bits that are below there. So typically if you use it in a proper way and you follow the 12 factor app rules, there's no real need to change the allocation of a virtual machine because it's a throwaway item. Just if you want a bigger one and the cluster controller says so, you just spin up a newer big one and throw away the old one and take it out of the load balancer. There you go. Yeah?
Anyone?
Yes.
What's the networking layer in Photon platform?
The networking layer in Photon platform, he asks. The networking layer in Photon platform, what do you guess?
NSX is necessary for Photon platform?
I assume NSX will be an integral part of the Photon platform. The packaging pricing stuff is not announced yet because the product is not out. But NSX is something because I think it's a new lifeline of VMware. If you look at where VMware is going as a company, NSX is a very, very big growth engine for VMware that delivers value for us. So you can see NSX popping up in almost any product of us. Even if you buy a mobile device management tool like AirWatch, we are positioned, I think, with NSX because we can do the application security from the mobile device until the bubble in the data center full end to end. So NSX will be part of Photon platform. Yeah. The logic at least. I don't think it's going to be a separate sellable product, but the technology will be in there. Because we are now working on integrating also with Docker and with Cloud Foundry to have NSX be the network platform directly for the container or the Cloud Foundry instance containers. So you don't have the network isolation and translation stuff anymore. So you can have a first-class object on your network for every virtual machine or a micro virtual machine connected to a network stack. So NSX, yes, it will be in almost every product.
What kind of isolation do you provide in Photon platform for the containers?
Well, it uses the basics of our ESXi hypervisor, but just a stripped down version of it. But the basics of the kernel are still the same, so it's still the isolation that people used to.
Does it mean that the Photon platform creates a kind of virtual machine per container,
Yes.
but a lightweight virtual machine?
Yes.
I
So
assume.
it's actually not visible as a. It actually just creates containers on top of a hypervisor. It's not seen as a virtual machine anymore. As with vSphere integrated containers, you still see a vCenter, all that. With Photon, you don't see virtual machines. You just see containers coming up as things running.
The
on
reason that
platform.
I ask this question is that there are some security concerns with containers. So if you
Yeah.
run multiple containers from different customers in the same operating system,
Yeah.
let's say in the same virtual machine.
Yeah, no, the fun part is because we run it on a hypervisor, you don't have that security concerns because you get that isolation. And that's why we think these platforms are up to production stuff, because a lot of people are doing. I don't know if you know the Docker security white paper. It's written by a VMware guy. There's a very big paper on how you do Docker security. It's a VMware guy. We use a lot of Docker containers inside on how we develop software. But the challenge is if you go into production and you get all the regulations. I saw when I walked in, I saw the ING slide on the thing. You know, if anyone is aware what happened at ING with running Docker and the fight they had inside, because you can't ship a black box with everything in it into operations. So I could just run this for me, because they've got these piles of paperwork with compliancy for banking that they have to apply to. And if they get this black box they can't see in it, they're not going to run it. So we need to find a way to do that smarter. And that's why I say that Cloud Foundry as a platform service is sometimes a much smarter approach, so you can check in code instead of checking black boxes that aren't visible to people do it. Underneath, it still spins up containers to do that, but it's you know what goes into the platform instead of not knowing what the wrapper brings with you. Yeah, go ahead.
Do you also plan to provide a Photon platform in your public VMware public cloud, vCloud Air?
Yeah, I suppose. Of course, everything we now deliver Cloud Foundry as a service you can put in there. When Photon comes out, I think it's essential that we run this platform ourselves to see and know and learn how to operate it at scale and deliver that as a service as well. So I haven't seen any exact timelines or roadmap on that, but vCloud Air, if you look at VMware software development, it's now the other way around. We used to have stuff that we built, we tested it internally, we gave it to our customer, and then we found out what was wrong with the platform, then we fixed it. So our customers used to be our testing dummies for years. If it doesn't work, they call support. You feed it back. You create a help ticket. You create a bug report, and the developer looks into it to change it. Now we have vCloud Air. vCloud Air is always our first customer. We delayed vSphere 6 because vCloud Air was deploying this very early stages, and they found trivial bugs that otherwise would happen at customers. So vCloud Air is now is our cloud first engine. So that's where we deploy things first, we scale it, we experience the pain ourselves, we improve it, and then we ship it to a customer so they can install it on their on-premise as well. So that way the quality of our software goes up big time. That's what we're experiencing right now with the transition of software development lifecycle inside of VMware. So yes, that's what you can expect.
Thank you.
Anybody? Otherwise we go for a small break.
Okay, thank you for your time.